Hello and welcome to our live Chalk Talk presentation presented by Cherwell Software. My name is Phil Bowermaster and I am Principal Product Marketing Manager with Cherwell, and I'm here to talk to you today about no-code development platforms and the special role that no-code development has to play in helping organizations to make the best of their digital transformation initiatives. And it's an interesting story because I think no-code has a unique role to play, not only in the era of digital transformation leading into business transformation that we live in today, but it actually has a unique role to play in the whole history of the digital era. And to explain that, we have to go back, way back, to the beginning of the digital era to talk about why that's the case. So I'm going to tell a story of the first true computer, So we're going to go all the way back to the very beginning of the digital era, the year 1946, and a computer called ENIAC was introduced at the University of Pennsylvania. ENIAC was built during the war, but the war ended before they could ever use it. They were going to use it for calculating ballistics of mortar shells and missiles and that kind of thing. But there was no more war, so the university got it, and it was unveiled as the biggest, most sophisticated, most complex, most powerful, fastest computer that the world had ever seen. It was tremendously powerful compared to any other computers. Of course, 1946, there weren't a lot of computers to compare it to, but it was hundreds of times faster than anything that had come before. To put it into modern terms, you probably have significantly more computer processing power in, say, your refrigerator or your coffee maker today than would have been found in a dozen ENIACs or 200 ENIACs if there had been that many. But there weren't. There was only one. There was one ENIAC computer. But I think it's the beginning of the digital age. And the reason I think that, there's two reasons. First off, it was truly digital. All the computers that came before were either purely analog or they were analog digital hybrids. But ENIAC was a 100% digital computer. And secondly, it was a multi-purpose computer. They were going to do ballistics and stuff with it, but unlike other computers that had come before that were designed just to crack a code or perform some other military intelligence function, ENIAC was what's called Turing complete, meaning it's a true multi-purpose computer. You can do any calculation on it. You can solve any problem with it, any computing problem. So, in a sense, ENIAC is the ancestor of every computer that we have today, including the device you're watching this on. If you're on a tablet, if you're on a mobile phone, if you're on a laptop, ENIAC is kind of the great-great-great-great-grandmother of all those devices. So I think that's why it's a good place to say that's where the digital era started. But what's really interesting to us about ENIAC, and the reason we're talking about it, is because ENIAC was a pure no-code environment. There was no code involved in programming ENIAC. You programmed ENIAC, that's why we're showing it here as just a bunch of cables and sockets. You programmed ENIAC by plugging cables into sockets and flipping switches. It was a very labor-intensive process to get a program to run on ENIAC, and once a program was running, it was essentially just a physical configuration of the computer. There was no real distinction between hardware and software. So a pretty difficult environment to work in, but people were very excited to have such a powerful computer at their disposal. And I think there's some interesting similarities between the challenges that they were trying to solve and some of the things that we're trying to do today. Because those early computer scientists, what did they want to do? Well, hey, we got a machine that will do anything. They wanted to test the limits of it. They wanted to see what kinds of problems it could solve. They wanted to innovate. And more importantly, they wanted to speed up innovation. They wanted to be able to do more faster. And they realized that if they were going to do that, they were going to have to empower their users. They were going to have to give their users more capability than they had. Because the problem, as I said, in a no-code environment was it was all physical labor. It took hours to program ENIAC, even a little bit. It took days, sometimes weeks, to get a program running on ENIAC. It was a very labor-intensive, time-intensive, unforgiving process. And once you had a program running, if it didn't work right, where was the problem? You had no idea. It was hard to test, it was hard to debug, it was hard to incrementally improve. So they said, we've got to do something to make our users more capable with this system. We got to make it a little less forgiving. And they had an idea. Although programming code didn't exist for computers at that time, it did actually exist. There was a form of code-based programming that was used in manufacturing. And you might be familiar with the idea of this if you've ever seen an old-time player piano work, where they got a roll of paper and it's got holes in it, and that's feeding instructions to a mechanism in the piano and it's telling it how to play. Well, that was actually used since the 19th century in manufacturing, primarily in textiles. You could put intricate patterns into cloth using that kind of system. So these computer scientists said, great, that's what we're going to do. We're going to automate computer programming. We're going to add some intelligence to the system. We're going to add some automation to the system. We're going to improve our experience of using ENIAC by adopting this player piano technology. And that's exactly what they did. Rather than rolls of paper, they took cards and they punched holes in these cards, and that fed instructions into the computer. And basically, I'm speaking at a high level here. This isn't exactly what happened, but you get the idea. We don't have all day. Basically, those cards told the computer where to plug the sockets, where to plug the cables into the sockets, where to flip the switches. So they automated that process. And what took hours before, or days or weeks, now took a very short period of time. In fact, you could probably say that each card that they punched that had a series of instructions in it represented several hours of work. And those cards with the holes punched in them were actually using a very simple binary code. So it was the beginning of the code era. They were using a binary code, zeros and ones, and it tremendously automated the process. It tremendously improved the speed at which they were able to innovate. It empowered the users, and they were suddenly doing a lot more with less. They were getting a lot more programs written and run in a much shorter period of time. So it was all great, and it was all goodness, except for the fact that binary code is almost as hard to work with as doing it manually. The problem is, if you've got a problem with the program in binary, it's pretty much the same as the physical configuration. You've got a bunch of zeros and ones. You're going to look at that code and say, I don't know where the problem is. Still very hard to debug, still very hard to test. So still very difficult to say, how exactly are we going to fix this problem? Well, they kept working on it, and over the years they came up with something called machine language. But the next really big breakthrough came in the 1950s at IBM. A developer there, a computer scientist there, had an inspiration. Hey, instead of speaking machine language, instead of talking to the computer in computer language, what if we had something that was like human language? What if we could give instructions to the computer in something that mimicked the way human language works? And thus was born Fortran, the world's first high-level programming language. It's not human language, but using that metaphor, we had a much more powerful way to give instructions to the computer. You see, it actually uses real words, right? Go to, if, read, else. You know, these are actual concepts that people could work with easily. It empowered those users, and it enabled them to do more with less than they'd been able to do. So suddenly, high-level programming languages existed. And as I said, if each card here represented hours of work there, each line of code here represented a card or two cards, or even a stack of 10 or 15 cards. So it was a tremendous compression of effort. They were creating a much better experience for their users in the process of adding intelligence and automation to programming. And that's when things really started to kick off, because of course Fortran was the first high-level programming language, and it was followed by Pascal and COBOL and Lisp, and all the way up to the modern era where we've got R and JavaScript and PHP and all the rest of them that are used to develop the applications that we use today. But this empowered the users, and it brought in a lot more users, because there's a much broader base of people who can write code than who would ever be able to do much with binary. There's a lot more people who can use it. It's a lot more usable to a broader group of people. And that's when computer technology really started to take off. So as systems like ENIAC began to evolve into mainframes, the technology that had been used just by the military and the government and academia suddenly gets the attention of business. Business becomes the early adopter of computers, and they start driving it big time, in the direction of speeding up innovation, empowering users, and doing more with less. And where that leads us is the mainframe leads to the mini computer leads to the PC leads to the laptop to the mobile device. And how people interact with them, the user experience that they have, is changed too. We start with command line interfaces, which leads to graphical user interfaces, which eventually leads to voice-driven and natural language interfaces that we have today. All of that starts going on in this period of time here, and we begin truly, for the first time, building out the digital infrastructure for business. It starts getting put together during that period. Meanwhile, around the time the PC is introduced, the next big breakthrough in programming occurs. Because code was great, and there were a lot of languages. I think one I didn't mention was BASIC, and Microsoft had a version of BASIC, which, according to the name, was intended exactly for the purpose of making it available to a lot more people, making it something that could be used by students, something that could be used by more or less regular people. Well, then they came up with a new idea and they called it Visual Basic. Rather than sitting down and writing basic code, you could take graphical elements, you could string them together, and that would give you your computer program. So, if each card represented hours of work here, and each line of code represented a whole stack of cards, each graphical element in Visual Basic represented many, many lines of code. So once again, we've got that compression of effort, we've got that empowerment of users and speeding of innovation occurring with the introduction of the first low-code platform. Well, things continue to progress. In terms of how computers work together, we start out with standalone machines, and then we have local area networks, and then we have intranets, and then we have the internet, and then we have the cloud. And suddenly, how computing is even managed changes, how it's even managed within business changes, and we start seeing things move to the cloud. Suddenly we've got not just software providers, but we've got people providing software as a service, platform as a service, infrastructure as a service. And with all that occurring, these drivers begin to shift. Businesses realize that it's not enough that we've built out a digital infrastructure, that it's time that we actually transform our businesses, that we need to have our business processes and sometimes even our whole business models worked through this technology, that this technology is going to support those and make them happen. It's not just something to help out, but it's something where they're actually going to live. So in the age of digital transformation, these take on, a whole new life. So suddenly we're not just trying to speed innovation, we're trying to drive business results with IT. We're not just trying to elevate the employee experiences in order to drive those business results. We're not just trying to empower users, we are trying to elevate the employee experience. And we're not just trying to do more with less, we're trying to achieve true IT operational maturity, to move from digital infrastructure to digital transformation. Well, how can we make that happen? In 2007, Cherwell introduced Cherwell Service Management, our first software offering, and it runs on Cherwell Core, I should say, our no-code platform. And this was the next big step, from no-code to low-code, and back to no-code again, in terms of a revolutionary new technology that can support this move from digital infrastructure up to business transformation. And let me talk about why that was the case. Cherwell Service Management is a fully functioning IT service management solution. And in the same way that the original ENIAC was designed thinking that they were going to use it for one thing, but it turned out to be applicable to just about anything you wanted to do with it, we learned that Cherwell Core is a platform on which you could run, yes, a fully functioning ITSM solution, but also one that you could do a lot more with. And here's what happened. We've got 5 patterns of workflow that you're going to find in any IT service management environment. If you're providing IT service management, you're going to be working on these 5 things: incident, request, change, knowledge, and asset. Now, you want to achieve IT operational maturity. In order to create new experiences for your users, you've got to get good at these things. Basically, Gartner says there's a 5-point scale for IT operational maturity. And if you're in the 4 to 5 range, then you're ready to go here. You're ready to start doing business transformation. Most businesses, unfortunately, are about the 2.7 score on that Gartner scale. So they've got a lot of work to do. Where do they work on it? Well, they need to work on it here. Because if you're doing these things right in IT service management, if you're handling incidents correctly, and basic incidents to really complex ones, I can't log on to the server's down. Requests, meaning we've got a process that exists and I need fulfillment on that process. Change, meaning we've got a process that exists and we need to alter that process somehow. Knowledge, meaning we've got something that needs to get done, an incident resolved or a process fulfilled, and the knowledge exists and it needs to be put into the hands of the people who can serve themselves and make that thing happen. Asset, the management of digital or physical assets. If you're doing these right, you're driving towards IT operational maturity. If you're doing these things right for IT service management, then you're going to achieve IT operational maturity and you're going to elevate your employee experience because these things are all going to be working well. But there's more to it than that. What we discovered at Cherwell was that our customers weren't satisfied just with doing this. They had a no-code platform on which they could develop their own mergeable applications. Meaning, yeah, you can use that no-code platform to configure and administrate your ITSM environment, but you can also build whole new applications from scratch, and that's exactly what they started doing. They took the ability to handle these 5 workflows, these 5 patterns of work, and they extended that out from IT into the enterprise. And Cherwell has moved from being a pure ITSM play to an enterprise service management play, to the point where last week we just announced Cherwell Service Management Enterprise, which is a full suite of enterprise service management applications, managing service management across the enterprise, giving you delivery of all these patterns of workflow. So our customers showed us how we could be in that space. We started developing solutions, but the platform is available to all. So we've got a Cherwell marketplace that includes applications developed by us, developed by our partners, and developed by our customers that address business problems across the enterprise. And that became the basis for which you could start improving these employee experiences. But it wasn't enough just to build out that IT operational maturity. We knew there had to be a greater focus on elevating employee experiences. We have to empower users by elevating employee experiences. Why is that the case? Well, the research shows, actually common sense will tell you, if you want to succeed in business, you've got to have happy customers. And the research shows that there's no stronger link anywhere than the link between customer satisfaction and strong employee experiences. If you want to have happy customers, you need to be giving your employees a good experience. The solid way to do that is to build a good infrastructure in which they can work. You want to automate what they're doing. You want to add intelligence to make it quicker and easier. The same things that we've been doing since day one still become the big issues. More to the point, you need to add new channels of engagement so that these employees can kind of choose their own experience. And just last week on this channel, Matt Clausen was showing CSM, Cherwell Service Management 10.0, and we have doubled the number of channels that users can access the platform with. So if you want to pick up your mobile phone and raise an incident on Slack, you can do that. You want to send an email, you can do that. Walk up to a help desk, you can do that. It's an omni-channel experience. Give people the experience, let them work in the channel that they want to work in, and they're going to be engaged, they're going to have a satisfying experience, you're going to have satisfied customers. So we've built out the platform to provide those kinds of experiences. We've taken it from IT operational maturity to elevating employee experiences through empowering users. And that gets us from digital infrastructure to digital transformation. But there's one more step to take. As Gartner says, if you're at 4 or 5 with IT operational maturity, you're ready to start talking about business transformation. All right? You're not just running your business on technology, you're using that technology to deliver the business results you were looking for. You're accessing it that way. Well, for that to happen, something even bigger needed to occur, and it has to do with the difference between a low-code platform and a no-code platform. Because we talked before about what a big step this was, where each line of code here where each picture here represents many lines of code here, and on down, scaling down. The thing is, there's still the lines of code here, right? If you're in a low-code environment, you're manipulating something else. It isn't always graphical elements. You might fill out a form, you might be using a checklist, but you're doing something that's driving code in the background. But with a true no-code environment, there's no reason ever to go in and edit the code. There's no reason ever to look at the code. You're actually working in that environment. And just as low-code opened up the user experience to new people who weren't comfortable doing code, and just as code opened up the new experience to people who couldn't do binary, no-code opens up this capability to the entire business. So if you want to go from IT to the enterprise, you need a no-code platform to do that. And with that, you're able to say, yes, I can support my designers, I can support my administrators, I can support my technicians, but I can also support these business users. And that gives us the age of the citizen developer. That's where we are. People out in the business who are defining their own experiences, not just by choosing their channels of engagement, which is important, but also by having skin in the game in saying, yes, I know this process. I know this particular problem area, and I'm able to go into this no-code platform, and I'm able to have a say in how this system is going to work for me. That is a huge change, and it's a full evolution all the way starting with no code, which told us, hey, we got to have a better solution. So we came up with code, and we said, hey, we have to have a better solution. So we came up with low code, and we said, hey, we got to have something better. We ended up with no code again. No code is the answer. It is the technology that can help a business that's worked out its IT operational maturity and has a good solid digital infrastructure, that has figured out how to elevate employee experiences and is working on digital transformation to truly achieve that business transformation and to drive business results with IT. It's very exciting stuff, and that's my story. Thank you so much for being with us. If you like this video, please leave a comment and like our channel, and let us know what other topics you'd like to see us covering in upcoming talks. See you next time.